Uh, did you hear that? Did you hear the sound? Okay. And and the lab 3, the lab 3 we told before. Okay. Okay, it's fine. And the lab 3 we told before, we can see the delay we need to test. And all of the delay we test is means that we test the longest delay. So, how do I test the longest delay in the three input XOR? It means that I must test like it passed three transistors because the three transistors means that the signal is past the most transistor I can see because of the three is the longest of the transistors, and we can solve we can test the longest delay. It means that here and here of this. Yep. So it means that A is 0, B is 0, and C is 0. It will test the longest delay from here. Okay, this is the lab 3 we've done before, and today we will talk about the LAB-4. Uh, we can install the LAB-4. We will done the dynamic CMOS logic circuit. Okay, and what is the dynamic CMOS logic circuit? It means that we done before is the static one, and the static one will now use the clock to control the output. And if we use the dynamic, we use the clock to control the output. So we can solve that. So this is our logic here, and we have the two clock to from the gate of the transistors of PMOS and NMOS. And this is the means that this is the dynamic CMOS logic, and whatever you've done in the logic here, okay, and we can solve here, and it means that if the clock is rising to from 0 rising to 1, and 0, and this PMOS will close, and this NMOS will open, and while if the input is from 0 to 1, you can show that the out one will pull down to 0, pull down to ground. So yeah, so the out one will be 0, and the 0 here will close the transistor, and the output uh so down to 0. And at the first time, if the uh yeah, we can solve here the clock here from the 0. uh, this one will open and this one will close. So it will have mm, a one. Yeah, here from here. Yep. So I will be one from here. And when I started to pre-charge, or when I started the clock from 0 to 1, and input is 1, and the output will go down. So at the first time, we can show that if clock is 0, this is 1, output 2, so the output 2 will be, yeah. So we can show that this is the dynamic CMOS operations like this. And we will start the three input dynamic XOR. It's very same as the last time you done, but this time you have two uh, all of the PMOS will be clock from PMOS of the clock, and most of the clock at the under of the logic. And you must done this like the tips to design your pattern. But I have to give you a pattern like this. But you need to test the pattern is correct or false. And what you need to do is like the last time we have told before. And the second one is the cascade, but you still need to done like a dynamic one. Yeah. How do I done like a dynamic one? Is like this. We are using the domino logic. Domino logic is means that this one maybe is the NAND here. We done the NAND here, and we have a out of one here to form inverter, and go to the second one. It's a domino logic, 1 to 1 and 1 to 1, 1 to 1. Yeah. Okay, and the last one is the 8 bit of dynamic Manchester's carry Manchester adder. So the circuit is like this. We have done the circuit, and this is a little like a test that you need to do by yourself. So I won't give you a example, and you need to design the pattern by yourself. And if you have any question, you can ask me in the line. If you really done the LAB-5 3, yeah. And this is a circuit that you can uh, you can solve. And after you finish the 3 lab, we have the question. The first one is what are the eliminations of analyze the pattern in the pre-charge and the evolution. It means that why we need to design like this. Okay, the second part is uh, analyze the cascade circuits of the circuit power and the delay. It means if I have just one NAND of the dynamic, what will the power and the delay? And if I have add more 3, 4, or 5 NAND, what will the power and delay will happen? And the third is explain why the domino series circuit is connect and what impact of the circuit function. And you need just like what I say, you need to answer this. And I want to know what is the advantage and the disadvantage of the dynamic circuit. So maybe you can say the advantage and the disadvantage of the dynamic circuit and the static circuit. Yeah, you can compare these two. And explain why the dynamic circuit is suitable to be used in the Manchester adder. So it means that one is the dynamic circuit can be used here. And I can told you after this four transistor is mean that the clock, and this is the clock. So this is the clock. Yeah, this is clock. Let's get of the clock. Okay, that's all. next week, or you can go to the lab. Yeah, maybe Friday, because I think the last one is the hardest one. Yeah, and I will send the things to you later. Okay.